All right, welcome, and good evening, good afternoon, wherever you are. So today's class, we are starting with Kubernetes, Kubernetes, Kubernetes. So Kubernetes has been a buzzword, right, in the in the industry, in the DevOps industry. All right. So Kubernetes has, because of its um ruggedity, because of how scalable, how enterprising, how flexible Kubernetes is, it has made Kubernetes um a, a commonly used container um manager. All right, commonly used container managing tool. So Kubernetes. What is Kubernetes? In a simple term, not too much grammar. In a simple term, Kubernetes is, is a tool for orchestrating containers. Maybe that's it. It's a too heavy language, very heavy language, orchestrating. Let me break it down. Kubernetes is a tool for managing the deployment of containers. So when you orchestrate containers, you're cooking, right? You are managing containers at a larger scale, at a very larger scale. That is what Kubernetes is. That's what Kubernetes does. And the feature that makes Kubernetes so adopted by a lot of organizations is because Kubernetes has a lot of features. It has a lot of integrations. So many guys, so many. Kubernetes is a big thing when it comes to DevOps. Kubernetes is a big thing when it comes to DevOps. But I think Kubernetes is overrated. Don't get me twisted, guys. It's overrated in the terms of getting to learn Kubernetes. All right. I just want to state it clearly in this class, explicitly. All right. In as much as you're going to follow us bomber to bomber, you're going to do all your watch your videos and practice along. Kubernetes is going to be very, very easy. Very, very easy. All right. Great. So this is what Kubernetes is all about. All right. So without further ado, let's now go into Kubernetes architecture. Now, before I go into Kubernetes architecture, Kubernetes is abbreviated. Kubernetes is Abi, abri, abbreviated as K8s. K8s. How come about K8s? So whenever you see K8s, you know that they are referring to what? Kubernetes. Now K8 means, look at this guy now. From this K, after this K, I'm going to count everything between K and S. It will be 8. U is 1, B is 2, E 3, 4, 5, 5, 6, 7, 8. So that is why it is what? 8, followed by what? The S. Kubernetes. All right? Great, guys. Now, let's now talk about the architecture. This lady, wait, one sec. Hmm. All right. Kubernetes, Kubernetes architecture. So we're using more of K8s. Kubernetes architecture. Guy, for you to understand Kubernetes back to back, you need to understand the architecture of Kubernetes. You need to know all the components. Even if you can't know all the components, know the commonly used components, the common components of Kubernetes. It's only when you can describe the architecture, you'll feel very comfortable with Kubernetes. You feel carried along. You feel you're on the same page with Kubernetes. All right. So I'll be taking my time to talk about the architecture. However, I shared the link. I shared the link in the morning. All right. I should read about the architecture and the components. If you have read, it's a plus. If you've not read, if you didn't read, so this is an opportunity. Oh boy. Kubernetes architecture. Kubernetes is divided. Guys, listen, oh, watch, oh, follow the flow. Kubernetes is divided into two parts. The first part is called the control plane. Guys, they pick this thing, no, pick them. As they drop them, they pick them. The second part, this is, I should change the topic of this thing. Kubernetes made easy. The second part is the worker node. So I'll push this thing. Copy and paste. I'll push the other. This is worker node 1 and worker node 2. Bring it down a bit. Oshé. Now, let me remove some of these no filler. Oshé. Give it correct. Come over here. No filler. Give it that. Give it let me give it blue. Similarly, come here. Give it blue. That's still come over here. That's no filler. Perfect. Diagram is gradually taking shape. Now I want to start with the control plane. On the control plane, I have somebody called controller manager. Put it there. Still on the control plane. I'm starting with the control plane now. I have this guy called the API server. Kube API, the API server. You can call it Kube API server. Keep it here. Then I now have somebody called Kube scheduler. Then somewhere here, I have somebody called the etcd. Then somehow, somewhere here, I have this guy called kubectl, a utility called what? Kubectl. Now, let's set up the connectivity. This is the flow from QAPI to what? To your API server. From controller, they all talk to what? API server. The etcd also talk to what? Gano cross API server. Then to manipulate everything in the cluster, API server. These are the components on the control plane. The control plane, aka the cluster. The cluster, the control plane is also known as what? The Kubernetes cluster. Your Kubernetes cluster has the Kube API components. These are the components. The controller manager, the Kube scheduler, the etcd, and the kubectl. These are the components, the fundamental components of the control plane. Let me arrange the entire structure, then I'll start definition. I'll start defining them. Now let's move over towards the worker side. On the worker side, we have somebody called kubelets. Kubelets. We also, let me copy this guy, copy and paste. Have somebody below here called kube proxy. Guys, I think all day beggar now. I cannot miss this class. Oh. No miss from the beginning. No miss from the beginning. If you do well as a DevOps engineer, this is the cross. Kubernetes is a cross of DevOps. All right. When this was after, okay, after they started easing up, easing up with lockdown during 2020. I had a lot of opportunity, guys. A lot from especially Germany. But you know what happened? It didn't scale through for me because I was just being handling learning Kubernetes with high level of levity. You know, I was just using my head and I go. A lot of guys that already have started doing things with Kubernetes. And then Jackpot. Then Jackpot. All right. So guys, you have to take this serious. Because we will start bringing the pieces together. We've done Docker. Okay, let me explain first before I talk that part. Now, there's a what? Kube proxy. We now have another guy called CRI. CRI is container runtime. Container runtime. I think that's all. We have similar, oh shit, man. Similar thing. We have similar setup here. Same setup. Now, look at the flow. Kubelets is the component from the worker side that links the entire worker to the cluster. to control plane. So it means that the control plane will get to know about the worker node through the kubelets. So here's the flow. So the component that connects the worker node with the control plane is the kubelet. So this flow is a back and forth flow. Similarly, every other thing in here, they talk back and forth. They talk back and forth. So this diagram, high level, the high level diagram of the Kubernetes architecture. Now, let's now start talking about these components one after the other. We're going to start with the control manager. Kubernetes components explained. The controller manager is responsible for managing controller processes. Okay. So guys, you need to perfect this diagram. You need to perfect the component as well. This thing has to be at your fingertips. You need to have it in your head such that even if you're when you're sleeping and you're being tapped, Toby, wake up, wake up, wake up, wake up. I bet remind me again the component of a Kubernetes class architecture. What are the components? The first thing first, you say you have to divide the architecture into two parts, into two halves. The control plane and the worker plane and the worker node. List everything inside of the control plane. Then list everything inside the worker node, worker plane. Now, this worker node, it's from the by the prerequisites, it is the minimum number of nodes, the minimum number of worker nodes that can join a cluster is 2. Take note, guys, oh, as they drop them, they pick them. The minimum number of worker nodes that could join a cluster is 2. Oh, I'll come on 1 second, guys. This one, okay, should not get the link. All right, 1 second, guys. One second. Oh, fuck, man. Ole, ole, ola. Ola, ole, ole. Ole, ole, ola. Chibiche is on me. All right, guys. All right. I was saying the minimum number of worker nodes that can join the cluster is what? Is 2. Anything less than 2, the Kube API server is going to complain. It's going to complain, all right? That you need 2. That 2 is needed for high availability. High availability. That 2 is needed for what? High availability. This was the what? Control manager. The next we have is the Kube API server. The Kube API server is the brain, or I would say the heart of the Kubernetes control plane. Every component, every component, every component of the Kubernetes cluster must have an endpoint to communicate with the API server. This API server has a lot of endpoints that eases communication to different Kubernetes components. Through this API, communication flows. Through the API, communication is eased up within the cluster. Within the cluster. Kube scheduler. This component is responsible for job scheduling. It is this component that will schedule the jobs, the tasks. It will communicate to the Kube API that say I want to schedule or I want to deschedule. It is the scheduler that is responsible for job scheduling. etcd, that is etc daemon. That is daemon. That is etc daemon. This component is responsible for storing all of the files, file systems, etc. Name it, services, metadata, etc. of the Kubernetes cluster. It's responsible for storing, it's a data house. This component is the data house. Data or storehouse of the cluster. All right. These definitions are just layman definition. All right. If I go in an interview with these definitions, anybody will understand to say, okay, this guy knows what he's saying. But I've given you, I've shared that material, that link for you as a first timer, as a beginner. You need to cultivate the habit of reading. When I drop a link, you have to read it. To your own good, though. To your own good, you have to read it. So as you have more insights. Me, if I'm going into an interview, I'm coming with experience. And when I'm talking based on experience. If there's something I don't understand very well, I'll just use my head. But as a beginner, you might find it difficult to use your head. So that is why you need to get exposed to these terminologies. Now, the last component. Okay. Controller manager. Before I come to the last component, I missed out something on controller manager. Controller manager, like we said, it manages other controller processes. Other controller processes like there's a node controller. There is a job controller. There is a service controller. There is a service account controller. There are a lot of controllers. Endpoint controller, this controller, that controller, object controller. Now, the node controller is responsible for managing anything nodes, which is the worker nodes. This controller manages worker nodes. This controller is responsible for jobs. This controller is responsible for services. This controller is responsible for managing service account. A service account is a user in Kubernetes. So a user in Kubernetes is known as a service account. All right. So that's the name. We don't call it user, we call it a service account. That's the technical name within Kubernetes. All right. As you have it on Linux, say I want to create a user, you say user add. Right. On Kubernetes, it's not called a user. A user in Kubernetes is called what? Service account. Take note, guys. Take note. Now, the last component on the what controller plane side is the kubectl. This component is a utility for the utility used for manipulating, configuring, setting up of services within the Kubernetes cluster. So for you to do anything within the cluster, you have to use kubectl. Kubectl is the command, it's a utility for interacting with the cluster. This is a utility for interacting with the Kubernetes what cluster. So for you to do anything on the cluster, you must install what? kubectl. This is the power of kubectl. This is everything about what? The control plane.
Quick question, please.
Yeah, man.
Yeah, I've tried to look at definition of endpoints in different ways, but I think it has to do with the use case you're using it. So what would you call an endpoint here? Because from your definition, if you scroll up a bit, when you're under Cube API server,
QAPI,
yeah, you said something about endpoint
with the endpoint.
on your definition. Every component of the
Because must have
K8s
every component of the Kubernetes cluster must have an endpoint.
must
Have
must have an endpoint.
an endpoint to communicate with the API server, right? So this guy creates diverse endpoints. So it is through that endpoint that it receives communication from every other component. The kube scheduler talks to the kube API through an endpoint, an API endpoint. So the API server has a lot of APIs. It's a reservoir of APIs that are there just to make sure that there's easy flow of communication from every other component. So it is the heartbeat of the cluster. So it's working 24/7. It works per nanoseconds. Before you go blink your eye, API server they work. Because if anything goes wrong with the API server, the entire cluster is down. Your API server cannot go wrong. If anything happens, everything is down. It is the heart of the cluster. Does that make sense?
Yeah, thank you.
Thank you. All right. The worker node. Let's start with the kubelets. This is on the worker node component. Kubelet. This component connects the workers to the cluster via the what? API server. This component connects the workers. This component connects the worker towards the control plane via what? The kube API server. That's the function of that guy. And every other functions. All right. So that's why I share that link with you guys. You need to go and read to elaborate from in an interview. Because everything is sharp, sharp. Give your state answer and move away. Give your answer and move away. No dulling. Just know one line, one function of that component. You say it, you drop it, and move to the next question. The next component is the container runtime. Container runtime interface. Benny. This component is responsible for building and making sure that um and making sure that the cluster government is responsible for building and managing the containers. This is a component that is used. This is the component that is used to create containers. You use a container runtime, a container engine. So it is this component that Kubernetes uses to create and manage the containers. The container runtime. Examples of container runtime here. We have Docker. We have container D. We have Cryo, etc., etc. So in Kubernetes, we will be using a lot of Docker. We will be using a lot of Docker. So on our cluster, we are going to install, not really on our cluster though. Using our cluster, yes. By tomorrow, by God's grace, we shall see how to build Kubernetes cluster from scratch using a tool called KubeADM. KubeADM. We shall set up a Kubernetes cluster. On the cluster, we are going to set up a container engine, which is Docker. Because Docker will be required to run the containers within the cluster. So Docker is required to run the containers within the cluster. That's why you have the CRI. Both the worker and the cluster and the server that will be your cluster, the server that is good, you're going to install the control plane on, they will all have Docker running. We're going to see Kubernetes on-premise. So that is called Kubernetes on-premise, which is termed as a managed, an unmanaged Kubernetes service. Unmanaged Kubernetes service. Unmanaged Kubernetes service, KubeADM, is a service where the controller, the etcd, the API server, the kube scheduler are being managed by you. You are the one managing them. It is after KubeADM. Then we shall go back to AWS to set up AWS Elastic Kubernetes service. That is the service we will use until this Kubernetes class finish. We shall show us how to create cluster, a Kubernetes cluster on AWS. That cluster will be called a managed Kubernetes service. It is called managed Kubernetes service because the control plane, the API, kube scheduler, etcd, a lot of every other add-ons are being managed by AWS. You won't see them. You won't see it. But all you're seeing that you're getting a cluster. The cluster is getting ready. So guys, follow me bomber to bomber so you don't miss out at any instance. All right, let's flow. That was container runtime. The last on that list is called kube proxy. Kube proxy. This component is the DNS component of Kubernetes. This component is responsible for creating networking. Networking, domain names, etc. So anything networking, it was the kube proxy. So that is it, guys. This is the whole flow. The entire of these guys, this thing, All of these is termed as Kubernetes architecture. Is termed Kubernetes architecture. At this juncture, guys, is there any question? One thing I left. We have objects, but I'll talk about those objects tomorrow. Kubernetes objects. So in Kubernetes objects, we have objects like the pod. We have replica sets. We have deployments. We have stateful sets. We have daemon sets. We have services. We have endpoints. We have jobs. We have ingress objects. We have persistent storage. We have config map. We have secrets. My dear Christian brethren, then plenty. All right? Then plenty. Shall do our best. All of these things will cover them. All these things we see. We are going to cover all of these things. So, guy, as a video drop, you have to be very close to your video. You have to be very, very close to your video. That being said, I want to see you guys tomorrow. Tomorrow, 4 p.m. dots, we shall start with KubeADM. KubeADM. If you have time to Google about it, to read about it, go and read about it. KubeADM. We shall set up KubeADM for Kubernetes. That being said, is there any query before I call it a day? All right. Since there's no query, see you guys tomorrow. See you guys tomorrow. Thank you. Thank you. And have a wonderful night's rest. All right, man. No wala, no wala. Too much. Too much. Too much. Too much.
All right. Thank you so much.
No, correct. Correct. Sunny, too much. Too much.